everyone. I'm Wazir Kubir from Concordia University of Canada. Our work is titled as Score Reliability Based Weighting Technique for Score Level Fusion in Multimodal Biometric System. In a multimodal biometric system, there are multiple matchers. So if there are multiple matchers, the performance obviously are not the same. One matcher may provide higher error rate than the other. So if this is the scenario for multimodal biometric system, the overall recognition rate is affected by the high error rate. So if the high error rate is present in the system, the overall recognition rate degrades. It could be solved by putting weight to the individual matchers. So a weighting technique is required before the fusion of the scores. So here we want to propose a weighting technique which is referred to as score reliability based weighting technique to estimate the weights of the individual matchers. So this is the block diagram of the proposed weighting technique. This is an example where there are two biometric traits. So after the classification of the traits, we will have matching scores. And if from the individual matching scores, a new set will be computed which is known as the reliability score set. From that reliability score set, we are going to compute the weights of individual matchers. And we will multiply those individual weights with the individual normalized scores, and finally we will sum them up to have the final fuse score for the final decision. So for example, we have the matching score set. So we are going to compute the reliability of individual scores based on the average of the score set. So for each individual scores, we will have the reliability score set using this formula, and the reliability is proportional to the weights of the matchers. So using the proportional formula, we are going to have the individual weights for the individual matchers. Then we are going to product it with the normal score to have the overall fused score set. The performance of the proposed method is evaluated using three biometric traits: fingerprint, palm print, ear print, and with the metrics equal error rate and genuine acceptance rate at 1% false acceptance rate. The first table shows the ER and GR of individual traits. The second table shows the ER and GR using no weighting technique, the simple sum, and some other existing weighting techniques. And the last row shows the performance of the system using the proposed technique. The table 2 shows if you have two biometric traits. So from this table you can see that the lowest ER and the highest GR is achieved by the proposed technique, which is 2.97 and ER and 94.13 GR. We have also tested it for the multimodal system, that means 3 traits. So if you incorporate one more trait, the equal error rate reduces more. So error of the system reduces more. And the genuine acceptance rate increases, which is 95.73 using the proposed weighting technique. So these are some ROC curves which is plotted based on the genuine acceptance rate and false acceptance rate. So from these figures you can see that the red lines which is the system performance using the proposed weighting technique, which is higher than all the existing weighting techniques and the unibiometric systems. So in this work, we proposed a weighting technique to estimate the individual matcher weights which will compute a higher weight for the stronger matcher and lower weight for the weaker matcher. This technique doesn't require any prior knowledge of the genuine and impostor score distribution or the equal error rate. And the performance of the proposed technique is superior to the existing techniques, and also it is superior to the unibiometric systems. Thank you so much. If you have any question, you are welcome to my poster session.